Okay, so this unit is called functions. So we're going to be learning how to do operations with functions, and we're going to do composite functions as well. Okay, so there's two functions on this first graph called f of x and g of x. So when we do a composite function including both of them, the domain can only exist where they both exist. So what is the domain of where they both exist? How far left can we go where they both are? -2. And how far right can we go where they both exist? Do you not have it? Does anybody, can somebody go through theirs and see if they accidentally got a double? Okay, and then how far right can we go where both functions exist? So I can go to 2. Okay, so we're worried about them both existing. That's the big idea. Okay, so I'm going to do this. -2, -1, 0, 1, and 2. That's the domain. Okay, now I'm going to do what is the f of x. So at -2, the f of x is at a height of, ooh, this is kind of awkward, I would say like 2.5. At -2, it's at 2.5. At -1, the height is 4, right? And actually just stays at 4 the whole rest of the time. Okay, then let's go through the g function. Okay, so at -2, the height of the g graph is at -1, then -2, then -3, then back to -1, and then, or sorry, -2 and then -1. Okay, ready. This first graph asks us to graph if the functions got added together. So all I'm going to do is going to take these two values and add them. So what's 2.5 plus -1? So 1.5. 4 plus a -2 is 2. 4 plus -3 is 1, 2, and 3. Okay, so now I'm going to graph that. So the coordinate is going to be like this: -2, 1.5. So that's my first coordinate. Then my second coordinate is going to be -1, 2. 0, 1, 1, 2, and 2, 3. And that's it. Okay, so you're going to do the same thing. We're going to do it subtracting now. So subtract, going back to these columns. So what is 2.5 subtract, wait, this actually, the order matters here, so we have to be careful. When I add, the order doesn't matter, right? Subtracting, you have to do it with the f subtract the g. So the f has to come first. So 2.5 subtract -1 makes 3.5. 4 subtract a -2 makes 6. 4 subtract a -3 would make 7. 6 and 5. Okay, so your coordinates are like this though. -2, 3.5. That's the first coordinate. -1, 6. 0, 7. Okay, I guess I should be putting some kind of label on my graphs for the scale, because making sure you're always doing that when you have to do a graph that doesn't have something on it. Okay. Then I asked you to do this one where it says multiply them. So multiplication order does not matter, right? When I multiply two numbers, it doesn't matter which way I go. Okay, so this chart will go -2.5. 4 times -2, so -8, -12, -8, -4. Okay, so your first coordinate should read -2, -2.5. You'll just have to improvise off the graph there, I guess, a bit at the bottom. Okay, and the last one is dividing, so that order matters, right? If we divide numbers, so we have to do it in the order the F number divided by the G number. So 2.5 divided by -1 is -2.5. 4 divided by -2 is -2. 4 divided by -3 is -1.33. -2, -4. Okay, place your 5 coordinates on there. Okay, so that is graphing functions with operations. Okay, so we're going to do operations on functions, but instead of graphs, I'm going to give you equations. Okay. Find the f of x plus the g of x. So the f of x is that function, x squared plus 3, plus g of x. And it's asked us to simplify, so what does simplify mean? Collect terms if you can, okay? I always get somebody who does this mistake. They try to factor it. Factoring is actually the complete opposite operation of simplifying. Okay, so I'm going to finalize it here. F plus g of x equals x squared plus 4x plus 7. Okay, because I put those terms together. Okay, the next one says to take the h function, which is x plus 1, minus the f function. So that is x squared plus 3x. Okay, this is a big deal. When you're doing a subtraction, you are going to need brackets on that because you're going to end up subtracting like that, okay? So that's very important. Okay, so let's finalize here. H minus f of x would equal, are you okay if I put my x squared first? Negative x squared and then I can put these terms together. X minus 3x, so that would be minus 2x plus 1, simplified. Okay, I don't know what you want to do there. Put a star beside that. You always have to distribute the negative symbol, okay? Okay, this one says we have to multiply the f function by the g function. The f function by the g function. So what are you going to do when you multiply something that looks like that in math? You're going to have to do a whole FOIL system. I need all 4 parts there. So x cubed plus 7x squared plus 3x squared plus 21x okay, and then simplified, I'm going to collect those ones together. Okay, D says to take the f function divided by the g function. Okay, there's nothing I can do with that. I could factor out an x on the top, but then it's x plus 3, and that doesn't get me anything to cancel or anything like that, or simplified. So I'm going to leave it, because I can't simplify it anymore. State the domain. What is the restriction on our domain when we go back to thinking about our rational units? So I have a non-permitted value here, and what is the number I don't ever want to be? And you look at bottoms of fractions, right? What's the non-permitted value? -7, because I don't want the bottom to be 0. So how do you want to write that? Should we write x can be any real number except -7? Is that okay if I write it like that? X can be any real number except -7. Some of you probably visualize graphs, and then that would be the same idea on a graph, kind of thinking like that. Okay, this next part says evaluate. So that word means figure out the number when you plug a 1 in. So this means your input for x. Okay? That's the x. So if x was 1, you would have 1 squared plus 3 times 1 over 1 plus 7. So 1 plus 3 is 4 over 8, or the output would be a half. Okay, number 2. Write an equation for h of x if h of x is the f function divided by the g function. So this time I need to pay attention to my titles of things. So h of x is when we take the f function divided by the g function. Could we simplify anything in that? Is there something we can do to simplify this? And this was from our rationals unit. We could factor the top. How do you factor that top? Which style is that one? Difference of squares. Okay, now, what is the non-permitted value here? I don't want x to be something on the bottom, right? Remember that? So I don't want -2. What happens when you get a cancel? What does that create? An asymptote or a hole? There's going to be a hole. -2 comma, what is the hole? Now plug in -2 here. What do you get? -2 subtract 2 would be -4. So there is a hole in the graph at that spot. So what is this if you graph it? What shape does it make? When you just have an x, what is that shape? It is a line with a hole in it. So what is the domain and what is the range? So you could do two things. You could go x can be any real number except -2. You can write it like that. Or you could do the brackets of intervals where you go -infinity up to -2 and skip over it and then go again from -2 to infinity. And what is the range? So can you write the range the same way? what are you skipping over with the heights? You're going to skip over the height of -4. Can you figure out how to write that the same way? So y can be any real number except -4. You could have wrote it that way. Okay. If you're okay, I'm going to skip example 3. I think it's the exact same as some other example I did. Number 4. Simplify y equals f of x, so the function f of x plus the function g of x. Okay, so this one is told me I'm going to title it y equals. It'll tell you specific things if you need to know. How do you simplify something that looks like this? You have to do some work to simplify it. You're going to need to square this. How do you square that properly? Big mistake is people squaring each thing. You're not squaring each thing, you're squaring the unit. So you're going to have to FOIL. Okay, I get that mistake. I get 50% of tests usually with that mistake on it. People forget foiling. Something squared, you don't square each thing individually, you square it as a unit. Okay, one more step is that you can collect the 36 and the 10. Okay, last example. Okay, h of x I gave you, so I gave you the final. Can you think of two functions that would add together to make that? So anybody could have anything random, as long as when you put yours together, they add to that. So think of something. So I might go x squared plus 5x. And then I would need a -7x minus 15. Okay, I can just make anything up as long as when I add them together, do those two add to the final? Okay, and then the last example is I need two things to multiply to get me that. So basically factoring. Which two factors would multiply to that? X minus 5 and x plus 3, right? Okay, so just trying to think of two things that multiply to that.